Good. So these were the talks for today. So now let's dive into some discussions and see what the future serves for us. I invite the speakers in the front to, yes. So thank you all for your presentations, and you've seen them, you see what they work on, you see what their specialties are. Now we want to get a little bit their ideas about the future. So to start a bit dynamically, we start with 5 simple questions. I make some statements about the future, okay? And then you put 5 fingers up if you really agree with it, or none if you don't agree with it. Does that work? Okay, so let's see. In 5 years, we will be able to predict natural disasters with over 90% accuracy. Therefore, no need for the current early warning systems. Okay, good. Keep in mind then to see to whom we ask questions. Okay, so nowadays, compute, you saw the mighty GPU, compute is so easily accessible that small models no longer make sense. 5 or 0? Don't take middle ground. Everybody, almost everybody, good, okay. Cool. Then, in the future, public access to high-resolution geospatial images, so really high resolution, will do more harm than good due to privacy concerns and security risks. Unanimity, there's nothing to discuss over here. Okay, good, good. Okay, 4th question then. It is AI, computer vision, plus Earth observation that will solve climate change. Oh, where's the optimism in this room? Okay. And final question then. In 5 years, pineapple on pizza will be universally accepted. Yes. Okay, okay, thank you very much. Then good start. So I think, yeah, I would like to hear, Thomas, then, why do you think that, I mean, you were the only one who did not put your arms up. Can you argument a bit your decision for that?
For the why small models might still be useful?
Yeah.
Yeah, I think there are certain problems within machine learning where if we try to use like the most complex model possible, we might actually just like overfit, or it might not be suitable for the problem. I think it really depends on what problem we're tackling. A lot of times, you know, very simple things like even like linear regression. I know this is not like applicable to like images or anything, but that could be like a better solution than like a multi-layer, like multiple like neural network or something like that. So I think we shouldn't like rule that out. And although, you know, like complex, like large models will give us like many of the most important insights we can get, we should never like just like discount like small models either.
Was any of you swayed by his argument? Or do you want to make a counter-argument? Benedict?
Yeah, I think it definitely makes sense for some tasks to have like small models. But I think like in 5 years, it will be more like a world where you just run your models on embeddings based on the satellite data. So you don't really have the actual data, you just have like the already pre-computed embeddings, and you just run your like small decoder heads basically. And so you already have like all the information you need basically stored in these embeddings. So I would say that that's more like the direction which we're gonna see in the next years. So you have like basically small decoder heads which basically do your task, but like it's like super expensive to run your models on all the satellite data out there. So you want to like minimize more the data transfer tasks more than like the actual model.
Very good, good middle ground there. Okay, cool. And then coming to natural disasters, Valerie, you were a bit not sure which side to take, it seems. What do you think? Will we use mostly then new techniques, or do we still use existing models?
I think it mostly depends on the type of natural disaster, because also in Switzerland we have, for example, a lot of landslide, and we know which area are likely to, where a landslide is likely to occur, but we still need those early warning systems to like tell the people don't go there at that time. And so I think it, like Thomas said, it depends in some use case, machine learning can be really good, and we should definitely employ it. And in some other application, other traditional method works really well, and we should stick to those.
Thank you. And Maz, you worked before in GIS. Do you take this board, or are you really wishing to put everything to ChatGPT now?
Let's put everything to ChatGPT. No, no. I believe there's traditional geospatial softwares, traditional geospatial methods are very valid. Now you're looking at new things coming out, such as those foundation models. Prithvi was something that's super interesting and a huge leap in what we're currently doing. Other organizations have also been releasing those big models for early warning. I'm not going to say any names, but some of them are quite valid right now. We're in the beginning of natural language processing for geospatial models, but I think it will give more access to people very quickly.
Good, thank you. Do you think then, so I don't know, maybe speaking on this last note of natural language processing, could it bring interpretability as well on top of the models if we have this, or does it take away from how we use them and models become more black box?
The models, in my opinion, is already a black box, to be fair. And for me, the interpretations at the end of the day is always the human. The human should be able to interpret in the way he or she wants the result. The model is here to assist and to give guidance, a general guidance of what's happening, and basically a way to take a better decision, to assist in decision making, but not make decision on the behalf of the humans. So definitely the interpretation side currently it's quite low, but as time moves on, then there's going to be a better sense of interpretation. But at the end of the day, in my vision, the human should be always the master of the game, I would say. Yeah.
Thank you. Lee, do you have what's your opinion on language as interpretability for the models?
I would say I would take the language as a tool for the human to communicate with the model. And for the interpretability, technically speaking, if you're adding languages to the model, maybe you have better image grounding of those models, which will bring like the technically interpretability to the model weights.
Thank you. Anything else? No. Okay, then think about the future. I showed this graph with a new space, meaning private companies launching a lot more satellites and then also producing data as very high resolution. From your field of work, what are the main challenges of treating very high resolution images? Benedict, yeah?
I mean, like, I see mainly like two challenges. Like, first of all, you have a lot of data. Like, if you like scale from like 10-meter resolution to like, I don't know, 1 meter, you basically scale your required compute by like 100 or something. So like going beyond 1 meter, it only makes sense if you have like super cheap compute, and like the compute currently is not that cheap, or if you can really. If you have basically use cases where you actually need this information, like if you do, for example, flood mapping, you don't need below 1 meter resolution, so it doesn't make sense to spend the money for the compute. Mm-hmm. So that's the first thing. And the second thing is that like all of this data is basically not openly available, so you basically have to pay for it. You might get it through Ether or something, but like I think like for having like open science and everyone can access this data and run their models on it, you basically need open data from NASA and Ether, like Sentinel-2 or Landsat, and that's like for the community itself, I guess like more important than having like this high resolution data where you have to pay a lot to get access. But of course, like for some use cases, it definitely makes sense. Like if you do like disaster analysis, things like that, you definitely want to have like this high resolution data.
Yeah. But we see because the data becomes available, then the use cases will come. So maybe today we don't think as much about them, but they will be. We use a lot for risk detection and all kinds of object detection, which is only visible in these ones. So I don't know, what do you think about the geographical differences once you introduce higher resolution? So maybe in Sentinel-2, you said your model works on the whole world. What if you introduce more higher resolution. Also from the language point of view, I guess the questions you might want to ask or the text descriptions changes, like somebody asked in the audience. So are there any challenges in adapting the geography when you have high resolution images?
I think the scale is always the core problem of remote sensing image processing. And especially by adding languages which will give a kind of a middle way of dealing with this problem, because regardless of the scale of your images, the language will always be in the same space to produce. So I guess I would say language as a plus to take the scale into account, but yes, it's a thing that we need to think about it, about the scale, about the model's general reliability across different scales of the images.
Maybe one short comment about scales is also when you have higher resolution label, you need higher resolution image, you need high resolution label, and then, of course, it costs more money to obtain those labels. They need to be more precise, also in terms of which category you need. So it's data, a lot of data problem.
I see. Yes, indeed, labels still are a problem, even if we do insert some language, right? So you mentioned that language is a nice way for non-experts to use these models, and then foundation models are a way for experts or computer vision to transfer these models. Are there other ways in which we can make the whole field more accessible? Let's see, maybe how can we be creative about this?
The first thing we may do is make everything user-friendly. I mean, I don't know if some of you guys in the room have ever seen a geographic information software or some of those big-ass Python libraries which are out there. They're very scary. When I look at them, I have anxiety. So a very user-friendly interface would be a start. Then, of course, nowadays the trend of having a chatbot to assist the user can also be a plus. When we think accessibility, we usually think user interface and user experience, but I think we also have to think deeper and look at disabilities, colorimetry, color blindness, and all those things to really take into account everybody and really have an inclusive vision of the tool or the solution we're building.
Yeah, I think going back to interpretability a little bit more, and especially like in terms of language models. So one example that I think was brought up before was like if you have an image and you ask like, is there a boat in this image? And it could say like yes or no. That's a good first step. But I think besides that, it would be nice to also be able to say like, why did you know that there was a boat in this image? Or just like have the model explain how it reached that decision. And what that could mean is running some sort of like interpretability analysis and then like encoding that information into the model so that it could like provide it as when prompted. Could be an interesting way to allow users to trust models more and make them more accessible.
Okay, thank you. Is there any question from the public then for the panel? Anything you want to hear them? Yeah. Yes.
Hi, Sapra, thank you for putting up a very nice panel. So I have a question for basically all the panelists, including you. So we see different roles of development of foundation models, big models, and small models, and how to apply that in field. And also the researchers are more focused on explainability and also how to combine multimodality data. So do you also see the same role in the coming decade, or how do you think that the different stakeholders can work together better to bring the field more accessible? And also, as an insurer, maybe you have something to say.
Let's let the panel first.
Sorry, just to clarify the question, like, was they asking, like, what can we do as like a domain to make it more accessible to other people? Yeah, I think really like providing good foundation models to like make it just easy to apply it to different tasks. Also like work on the package. That's how you use the data. It's like, I totally agree. It's like super hard to like get started with geospatial data, and to just make it easy for everyone in computer vision to like work with satellite data, easy access. Also having like data sets with multispectral data, not only RGB images from Google Earth. I think it's also like quite important to get into the domain. And also like if you look more on like domain experts, really having like low code or no code solutions, like for example chatbots, to really like enable everyone to use these foundation models you described. So I think like it's basically these two parts.
To speak a little bit about some numbers, currently the industry roughly represents about 78 billion in terms of the market size. It's hoping to double in the next 4 years, and it's going quite quickly. By 2030, it's going to be around about 200 billion US dollars. So not only the industry is growing, in the geospatial industry in general, research is growing as well. More people are getting access to it. But then how do we prevent those people, and it's a question I'm asking myself as well, to get easier access to this industry that's growing, to the amount of research that's coming out, to everything that's open source and open data that's already out there, the amount of data. How do we, as the geospatial community and as the Earth observation community, do that? And it's something that I would like to also hear.
For me, I think the most important part is the data. Open data, not only for the RGB images, but also like the special images we would face for the remote sensing field, will like significantly boost the development of those models and open those models to the public. And also as like find more interest for this kind of geospatial foundation model into the real world application, will give a chance for those models to bring them to the broad public, I guess.
That's a great note to end on. So thank you very much. Let's thank our panelists. I guess it's time for coffee now. Hope you're all excited.